So in this video, we're going to be talking about how to convert rectangular coordinates into parametric equations and how to graph parametric equations. So if we have a line that when we write it in point slope form, y minus k equals m times x minus h, and we want to get that into parametric form, we can rewrite it as the following: y minus k equals, we can write m as some number a over b times x minus h. And then we get the two equations, which are y minus k equals times b and x minus h times a, and we can set both of them equal to t. Because here we're saying this part is equal to this, and if this is equal to t, t is equal to t, which is equal to this. By the transitive property, they are equal. And now we relate y to t and x to t. And then solving for x and y separately, we get that y is equal to 1 over b times t plus k, and x is equal to 1 over a times t plus h. So given any line, we can write it in point slope form, and from there you can make it into a parametric equation.
Do I stop?
Alright. And now for an ellipse that is written rectangularly as x minus h squared over a squared plus y minus k squared over b squared equals 1. You use the trig equation sine squared is t plus cosine squared of t equals 1. And each one corresponds so that you set sine squared t equal to x minus h over a squared, and cosine squared t equal to y minus k over b squared. And when
then
you
from here, solving for, you can solve for t by simplifying the equations. So let's see, sine of t is equal to x minus h over a, and cosine t equals y minus k over b. And solving for x and y, we get x equals h plus a sine t, and here y equals k plus b cosine t. And it's pretty much the same thing with hyperbolas. You know, the standard form of the equation with a hyperbola is like so. Except to convert into parametric form, we use tan squared t minus secant squared t equals 1. This is the same as that equation, except we divide everything by cosine t. And this corresponds to this, to this, and 1 is equal to 1. And we set tan squared t equal to x minus h over a quantity squared, and secant squared t equals y minus k over b quantity squared. Solving for t, actually solving for x and y, we have x equals h plus a tan of t, and y equals equations are what describes the rectangular coordinate equation of the standard form of the hyperbola. And the conversion for a circle equation is the same as the ellipse, except b is equal to a. Where b is equal to a, then the denominators are equal, and then you can factor out the denominator and multiply both sides by that, and that would be your r squared. So if a is equal to b, then you have the equation of a circle. And as for graphing parametric equations, your x-coordinate and your y-coordinate are determined by separate equations. So let's say x equals t minus 1 and y equals t plus 2. Come on, 2.
Wordsmith, yeah.
So let's just pick time. Let's just pick time t0. If we put t equals 0 in here, we get the coordinate at t equals 0. We have negative 1, comma 2, and then t equals 1. We get 1 minus 1, 0, comma 1 plus 2, 3, and t equals 2, 3, 4. And so on like that. And then if you plot it, you would just plot it like any other rectangular coordinates, because once you plug in all your t values, you get separate rectangular coordinates, and then you can graph that. So negative 1, comma 2 would be like here, 0, comma 3 would be here. And then this is the equation of a line. So if you connect the dots, your equation, the parametric equation, would result in a graph that basically looks like that. And you have to determine the direction of your motion in the graph, and here we know as time increases from 0 to infinity, the points progress from bottom left-hand corner to top right-hand corner. So we can write the arrows like this, and the direction of the motion is this way. And that is basically how you graph parametric equations.